Okay, this video is about taking a polynomial and factorizing it into 2 or 3 brackets. And the way you need to go about doing this is to do it in 3 steps. First, by just trying some factors based on the constant at the end. So like in this case, negative 64. So you want to guess something. The second step would be to use synthetic division to simplify that polynomial a little bit. You should end up with a quadratic, and so in the third step you would factorize that quadratic to get some factors. So in this video I'm going to break down these steps for you so that you can follow along and know what to do every step of the way. G'day guys, this is the math base. Alright, so we have a polynomial cubic, which is x cubed plus x squared minus 64x minus 64. The first thing you want to do is list out some factors of that 64 that you have at the end there. 1, 2, 4, 8. These are all possible factors, and the list goes on, but most of the time you'll be given questions that have a small factor to begin with. So there's a really good chance that it's going to be one of these first 4 smallest factors. So the first thing we're going to try is x equal to 1. And if that doesn't work, then we will try the negative version of that. So for x equal to 1, if you sub the value of 1 back in, we'll find the polynomial is equal to negative 126, which is not equal to 0. The aim is to get 0, right? If you get 0, that means that x is actually a solution to this polynomial, or in other words, it's an x-intercept. So let's try x equal to negative 1 and see if that gives us 0. Subbing that in results in a negative 1 plus 64 minus 64, and that equals to 0. So we can say that x being negative 1 is a solution, and we can conclude that x plus 1 is a factor. This connection between solution and factor is known as the Factor Theorem. So the next thing we need to do is take our polynomial and divide by this factor that we just found, x plus 1. If you use synthetic division, then it's going to look a bit like this. And what we get at the end is x squared minus 64. And just remember, if you are dividing a factor, you should get a 0 as your remainder. So you can use that to verify if you've done it correctly. And guys, if you don't know how to do synthetic division, then please have a look at my videos that explain how to do that. It's much quicker, much easier than using long division. Links in the description. Okay, so the answer I wrote at the bottom, that's basically the usual form of what you get when you divide something, but you can also write it in a polynomial form by basically just rewriting the polynomial as x squared minus 64 times x plus 1. So at this point, we want to do the third step, which is factorizing the quadratic, because there's a good chance that could split into 2 more factors. Factorizing x squared minus 64 gives us x minus 8 times x plus 8. This leads us to writing a simpler version of the polynomial where it's made up of 3 simple factors, x minus 8, x plus 8, and x plus 1. And that's the end of that. So this is what a fully factorized polynomial looks like. And there's many variations to this type of question, so we're just going to have a look at another one right now. So here we have negative x cubed plus 43x plus 42. This one's a bit different because it's missing the x squared term. So as usual, you want to list out factors for the constant 42. And that would be 1, 2, 3, 6, and 7. The list goes on, but chances are it's going to be one of the first 3 or 4 numbers. Alright, so let's try x equal to 1 and see what we get. Okay, so it ends up being 84, which is not 0, which means 1 is not our solution. So let's try the negative version of that. If we sub in negative 1 into the polynomial, negative 1 cubed just stays as negative 1. Negative 1 times 43 turns that into a minus 43. And since there's a negative at the front of the negative 1, that also changes it into a positive. So you have a plus 1 minus 1, which gives you 0. That means we also have negative 1 as our solution in this question, just like in the last one, which basically leads to saying that x plus 1 is a factor. You always want to flip the sign when you're turning a solution into a factor. So at this point, you want to do the second step, which is dividing using synthetic division. We'll find that our quotient is negative x squared plus x plus 42, while our remainder is 0. So that indicates that we probably did this right. From here, we need to factorize this quadratic. Just keep in mind that if this can't be factorized, that means it's an irreducible quadratic, which would mean that you're supposed to just leave that as part of the answer. But in this case, we can factorize it, and first we would factorize the negative 1 just to make it a bit easier, and then we find that our two separate factors are x plus 6 and x minus 7. So the polynomial can be rewritten as negative x plus 6 times x minus 7 times x plus 1. So I hope those steps and that explanation made sense to you guys. If you have any questions you would like me to work on, let me know in the comments below as well. I'll be happy to provide some kind of work solution for that. So if you get how this works and factoring comes easy to you, then you can take it a step further by sketching the graphs as well. It's not perfect, but you can just sketch it based on the x-intercepts. And I won't go into detail on how this is done in this video. Maybe I'll make a different video for it. But basically, you can use the x-intercepts in conjunction with the a value and the type of factors you have, whether they are linear factors or quadratic factors, that sort of thing, and putting that information together to figure out what sort of curve this is giving. So I hope you guys enjoyed the video. If you found it helpful and informative, please drop a like for me. And you can also comment below to let me know what you would like to see me teach in the future. I upload videos every Friday, so if you guys haven't done so yet, please subscribe to the channel and ring the bell so that you can get notified for when the next video comes out. Thanks guys, see you next time.